Alright, so this is some iteration. If we were to work out what's going on here, we are basically feeding in a number into our code. So let's imagine it was 5. So n would be 5. And we're tracing this through. So we're going to be going from 1 to n plus 1, so 5 plus 1. And what we're going to do is we're going to simply add I to our result. So the first time it loops, it's going to be 1 plus 0. The second time it loops is going to be 2 plus 1. The third time it loops is going to be 3 plus 3 equals 6, because we've got our I, which is counting up in order, 1, 2, 3, and we're adding it to whatever's in the result. So now the result is 6. So 4 plus 6 equals 10. And then we've got 5 plus 10 equals 15, which means that we're on end because we've done it 5 times. 1 to 6 is 5 times. So we're done. So that is what it's going to produce if we return the result, 15. The magic 15 there. So if I was to call this, it'll be sum first n iterative 5. Obviously we'll change this to n. We'll change this to n. And result equals. And if I was to simply print result, just so that we can see it being built. Let's put the result at the bottom so that it has a chance to add the result first. There we go. Okay, so it keeps adding it every time it loops. So your challenge now is to write the iterative version of this. How would you write the iterative version, sorry, not iterative, the recursive version of this? Pause the video, give it a go, and then I'm going to do a solution with you guys. Okay, so what I'm going to do is I'm going to move this down the page. I'm just going to copy this. And we've got that there. Our first step is to identify the base case. And what another way of saying this would be is, what would be the smallest input size that we can enter into this function in order for it to actually be summed and make a difference? So what I mean by that is, if I was to put in 0 here, if I run the code, nothing's going to happen. Well, that's also, yeah, nothing's going to be added to it. It's just going to be empty. So we can't use 0 as our base case. That's not the lowest number. But what about 1? That is the lowest we can go. So we established that the base case is going to be 1. That's a minimum value we can enter, which will really make a difference to the algorithm, well, allow it to work. So I'm going to make the function again, but this time I'm not going to call it iterative, I'm just going to call it recursive, because the recursive version makes sense. We now need to establish our base case. So if n equals 1, we want to return 1. That is our base case. That's a minimum value we can enter. What we're going to do now is I'm going to basically call this so that we're ready to use it. And let's just pass in 5. Let's have a result. And let's then do our recursive course. I'm going to have total equals sum first n recursive. And I'm going to put n minus 1. And I'm going to go through that in a second of why. If I was to just do print n up here, our step 1 is similar to how we did the trace tables. I'm going to hit run, and it's going to put these into a stack 5, 4, 3, 2, 1. So we put it into a stack. What I'm going to do now is I'm going to add an extra line of code here, which we don't really need, but I'm going to use it just to show you what happens in recursion. So I'm going to make a variable called result equals, and it's going to be total plus the sum, total plus n. And I'm going to hit print result. I'm just going to return the result, because that's what it's expecting as it's a function. Now, I'm going to hit run. And do you know what? I'm going to add my n to it as well. So let's do print, let's just make this a little bit neater. Let's do it n, and then I'm going to do a comma, speech marks, add, comma, and then let's have total. I'm just making this look neater, you'll see what I mean in a second, equals result. So if I run the code now, oh, I made a boo-boo. And that is because of this. This needs to be a comma, and this needs to be a comma. Now let's run it. So, these are ends, these are totals. So 2 plus 1 equals 3, 3 plus 3 equals 6, 4 plus 6 equals 10, 5 add 10 equals 15. Boom, done. So our step 1 is to literally do this. What this is doing is putting it into the stack. Then what we need to do is add up the total plus n. Now, so what we're doing is we're simply adding n to whatever's in total. And at the end, output a result. Now I can make this a little bit more efficient, as in less lines of code, because all I need to do is simply return n plus total. So if I run this now, I need to print result in the main code, and all that's going to do is give me the final result, which is 15. Done. So my step 1 was to find the base case, then it was to put it into a stack, then it was to add the totals to the stack, take the totals from the stack and add them to n, and then return the result. So let's try this on a new problem, and let's see if you can do it yourself first. This is our code. You can kind of, even without this title, I could call this whatever. You should be able to work out what is going on from this code. I want you to turn this into its recursive alternative. So pause the video, give it a go. Okay, so what you should have done is created a function. The function, I'm going to give it a different name. I'm going to call it recursive instead of iterative. That's the easy step. The next step is to identify the base case, which is going to make the minimum value. Well, we know that 0 isn't going to make any difference to this. It's not going to allow it to run because we're starting on 1 to start off with, so it's not going to work. 1 times 0 does not work. Also, as I said, we're starting on 1. So our base case is going to be if n equals 1, return 1. I'm then going to add items to the stack. To add items to the stack is very easy. To add items to the stack, I'm going to create a total equals the name of the function, so that'll be adding items to our stack, n minus 1. Great, done. Finally, we need to do our calculation. So our calculation is going to be multiplying by I. So it's going to be return n multiplied by total. And that's it. Next week, I'm going to give some slightly more complicated versions of this.